So we'll continue with the pseudo force again. So as we discussed already about what is pseudo force and when this pseudo force will come into the existence and all. So if you have noticed it, basically, this pseudo force, basically it is a fake force. It is not existed. Just only we will experience it when we are in particular situations. So if you know, we all studied in the last chapter, laws of of course, this chapter only, Newton's laws of motion. So mainly Newton's second law, if you observe very carefully, this Newton's second law, whatever we studied that, what is the Newton's second law? Anybody can tell? All of you, F is equals to dp divided by change in momentum divided by
change in time taken.
Change in time taken.
That is what is the law. So this law, Newton's second law, is only applicable. So it is completely depends on someone. Can you tell me what is that? It is depends on observer. Okay. So based upon the observer position, the Newton's laws may be applicable or may not be applicable. So only Newton's laws are valid. So Newton's laws valid and not valid. So there is a two situations. So where the Newton's laws are not valid, so in this case only there is a particularly we'll consider as force which we used to call as, what is that force we used to say? It is only called as pseudo force. Now, so as we already taught, observers, the Newton's laws are valid only when the observer's acceleration must be equals to what? Observation acceleration must be equals to 0. Means in the sense of, if observer is having a constant velocity. So if it is a constant velocity, means acceleration is what, guys? Velocity versus time graph. It will be parallel to x-axis. Am I right or wrong, everybody? So in this case, acceleration is equals to 0. So if the acceleration of a body is 0, then when the velocity of the body remains constant, then this is called as, we basically called as inertial frame of reference. So in this case, the Newton's laws are valid. But if it comes to that, if the observer's acceleration is not equals to 0, means in the sense of v changes. So v can change by two ways. Velocity can changes by two ways. Anybody can tell what is the two ways we can change the velocity?
Magnitude and direction.
One is by direction and another one is what? Everybody. Another
Magnitude.
one is by magnitude. So by changing the direction as well as the magnitude, if the velocity is not constant, so v continuously changes, then we used to call acceleration of the body is not equal 0. Then in this case, you can notice it. So the Newton's laws are not valid. Mainly which law? Mainly the second law is not valid. So in this case, this is what we used to call as non-inertial frame of what? Reference. That is what. So basically, if any kind of observer, we have solved many pulley sums. If you notice it, so if there is a pulley, for example, if the pulley is pulley basically will use to lift the weights. So there is a weight M1 and there is another weight which we used to say M2. Now, if observer is observing from the ground, of course, Earth is basically in a motion. It is an accelerated motion because in a circular path, continuously body is said to be in accelerated motion or not? Everybody? Yes or no?
Yes, sir.
Because at every point, what will changes? In circular motion, magnitude of velocity may not change, but something it changes. What will changes, everybody?
Direction.
Direction. So that is why circular motion we used to call as accelerated motion. So velocity at every point is not constant. Direction keep on changes. So as if you consider ground, so ground or earth, v direction keep on changes. So it is inertial frame of reference or non-inertial frame of reference, everyone? It is a non-inertial frame. Acceleration is not equals to 0. So it is called as inertial or non-inertial, everybody? It is called as non-inertial. But what we are assuming? We are assuming, as we all knows, that Earth will take much time. Like we know Earth velocity is very, very small. It will travel very slowly around the sun. So it will take almost how many days? 365 days to complete one rotation. Understanding? So we will assume that, assuming that the Earth acceleration is, Earth velocity is very, very small. Do you understand, all of you? So as we know that Earth velocity is slow, very, very small. So we people will consider as, even though it is a non-inertial frame, if the observer is standing from the ground, we'll consider that his acceleration is what, guys?
Zero.
His acceleration is zero. Because Earth is moving very slowly. So it's very small. Due to this reason, even though it is a non-inertial frame, we have to consider as a what, everyone? We'll consider as inertial frame. Okay,
Inertial
everyone?
frame.
So that is what. So if the observer is seeing any kind of thing from the Earth, it is inertial frame or non-inertial frame? It is the inertial frame. Understand, Aswita? Isali? That is what. Now, let us solve this question now and we'll continue that. So when this Newton's laws is true, that is what we should observe. So always keep in mind, Newton's laws are always true only if the acceleration of the observer is zero, means his velocity remains constant. So then only the Newton's laws is applicable. If not, then let us see. So what is this Newton's this pseudo force and all? As I told you, the best example, whenever your school bus or your car, whenever you see that, whenever your father will take a sudden turn, you can see you will be pushed away from the away from your seating and you will fall towards the mirror or towards the window. Have you all experienced it? Yes or no? All of you? Yes, please. So when you are traveling in a car or something, you can check it tomorrow when you're traveling in bus. On the day also I told you. So there is a force. Actually, it is not existed, but due to the sudden change in the direction, you can see we people will fall towards the window. So that is the force actually, which is not actually existed. Nobody is pushing us towards the window or door, but we are falling because of sudden sudden changes in velocities of a car or something. So that force is only we used to call as the force which is existed by that time. What is the force we used to call? Everybody. We used to call that pseudo force. Actually, the force is not existed, but we are experiencing. So that is what we used to say pseudo force. Now, let us consider the lift sums and we'll solve it. If you notice it, for example, let me consider. So there is a lift. We all know two things we studied. One is string. Another one is what, guys? Spring. Okay. So do you all remember that difference between the string and spring? Everyone? Yes, please. Yes. Yeah. So if you notice it here, so let me consider there is a mass M inside the lift. Now, lift is traveling with the acceleration A and observer is in ground. So now tell me, it is a frame, inertial or non-inertial frame? Everybody. It is a
Inertial frame.
Inertial frame. So now, if you observe this observer A, observe this mass. So this lift is appears to be going upward or not? This mass is appears to be going upward or not? Everybody. Yes or no? Yes. So the weight of the body is acting downward direction mg. The tension in the string, what is called as? Tension in the string we used to call as T. Yes, all of you. So there is a tension which is called as upward direction. So if I study FBD means what, guys? Free body diagram. So tension and G. So if you notice it, what is the net force? Everybody, net force is equals to MA. So what is the answer? Can you tell me that? T minus
mg
acceleration is
equal to
upward direction. So T minus mg, which is equals to how much, Ra? M. So what is the tension? Tension in the string is equals to mg plus mg plus. Yes, please. mg plus me. Now, let us take the same observer. Now, the observer is inside the lift along with the mass. Now, the mass m is going upward with the acceleration is A. Now, you tell me, if the observer is now observer is inside. Now, you tell me m appears to be in state of motion or state of rest with respect to observer. All of you. State of speak. State of what?
Rest.
Rest means in the sense of what is the m acceleration? M acceleration is equal to how much? Acceleration is equal to how much, Pradosh? Observer is inside because observer is acceleration also lift acceleration. Am I right or wrong, everybody? Clear or not? Understand, Rudreswa?
Yes,
that is. So observer is also having the same acceleration. So that is the reason the body is appears to be in state of rest. Means what is the acceleration of the body? Mass M.
Zero, sir.
Zero. So then the mass, the forces which is acting, tension which is acting upward direction T, and weight of the body is acting mg 0 and acceleration is equal, sorry, mg is downward and acceleration is 0. So means in the sense of, then what is the forces? Acceleration is 0 means both the t is equals to what?
mg.
T is equals to mg. So this is the tension in the string if you observe it. Okay, so this is the tension which is acting here. So that is the difference between when observer is seeing from the ground, when the observer is along with the mass. Now, so let us use instead of string, if I use suppose, so I cannot measure the weight or the force or tension, okay, in the string. So let me take the, instead of string, I can modify the string into what? I can modify into what, guys? Spring.
Spring.
Then let us see what is the spring balance reading. So which is actually correct? If you go to the lab, so which is correct? If the observer is seeing from the ground or the observer is inside, so which we will consider it. So let us discuss that. So we start now. Everybody clear? Shall we proceed?
Sir.
Yes. So now if you notice it always, all of you remember, instead of spring you consider as a string. Sorry, a string you consider as a string, and you can consider. So use spring balance. Use spring balance and measure the weight and which is correct. That is what we should verify. So now if I use the spring, so as we know, there is a lift. So inside, and observer is outside or inside? Observer is outside. So observer is outside means what is his acceleration? Everybody.
0.
Acceleration is 0 and the lift is going upward direction. Lift is going upward direction. So in this case, the spring force is equals to, the spring force equals to something. What is that? The spring force is equals to tension. So that T is equals to the spring balance. How much it will source? Everybody. Spring force. T is equals to spring force, which is equals to how much, Ra? It is going upward
FC.
direction. So what will happen? Mg plus Ma.
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 Plus Ma. So that is what, if I replace the string with what? Kadosh? If I replace the string with the spring, so we all know that spring force is equals to tension. So tension is equals to mg plus ma. So this is what actually the spring balance will source. So spring balance reading. So now all of you remember, if the same thing, if it is goes non-inertial frame, if it is non-inertial, so that what will happen, all of you? So let us modify the string with the spring. Now if you have check it, all of you, so observer is inside the lift. Now observer's acceleration is also same as the lift acceleration. So by that time here, acceleration of the mass is appears to be how much? Body is appears to be in
0.
what? State of rest. So if I check the spring force, then the spring force present in this F is equals, FC is equals to tension. So tension is equals to how much it will come?
MG.
Is equals to mg as acceleration is 0. Then, so if you go to the lab, so which is actual reading? So what is the correct spring balance reading? So either this one or this one. So we all knows that always NLM, Newton's laws of motion, is applicable only for the what case? Inertial or non-inertial? Everybody. It is for inertial frame of reference. So keep it in mind. This is the actual reading in lab. Okay, so in lab, wherever you go, this is what the weight we are measuring, the tension, whatever we are measuring, this is the actual reading, and this is not actually correct reading. So that is what always observer must be. We'll consider what is the acceleration of the observer. Acceleration
0.
of the observer must be 0. Then only the Newton's laws is applicable. So always keep that point in mind, everybody. Newton's laws of motion hold only for which observer? Everybody. Inertial or non-inertial? Inertial observer. So please note that point. So in Newton's laws is applicable only for what observer? Everybody? Inertial. Okay, so that is what you should know. So as I told you in last class, you all remember that Newton's laws is applicable. We people can apply Newton's laws when we consider the force which is exerting. That is what in pseudo force case. So how to make the Newton's laws of motion applicable? That is what we'll discuss. So in case of pseudo force, let us discuss either the Newton's laws of motion is valid or not. So to apply NLM, to apply NLM. What do you mean by NLM? Everybody. Newton's
Newton's laws of motion.
Newton's law of motion.
non-inertial frame of reference. Non-inertial frame. So non-inertial frame means observers. Observers, if it is non-inertial observer, then it's very simple. What is the Newton's second law, everybody? Newton's second law, F is equals to what? Mass into acceleration. Now, pseudo force. This is force, normal force. The pseudo force is equals to just opposite that. Opposite to that, that is what? Minus ma. That is what we can say. As we all knows that acceleration means, for example, like body is accelerating like this, then the pseudo force is acting opposite. That is what will represent the pseudo force with what sign? Everybody?
Negative sign.
Negative sign. Okay, so that is what? Minus ma. If I write it, this is only called as what force? Everybody, who is to called as?
Pseudo force.
Yes, please. Pseudo force. Clear? So this pseudo force exerting on the object, if you have noticed it, so it depends on what? It depends on mass of the object, and as well as next one, A. A is a what? Acceleration of body or acceleration of observer? Everybody.
Acceleration of observer.
Acceleration
Observer.
of whom?
Observer.
Acceleration of observer. And if suppose if observer acceleration is upward direction, then the pseudo force direction we have to consider what direction?
Downward
Opposite.
direction.
That is what? Minus. So this minus always indicating opposite to what? Everybody. Opposite to what?
Acceleration of observer.
That is only called as pseudo force. Clear? So that is what let us discuss now. So if you observe very carefully now, so if we consider there is a lift non-inertial frame case, so there is a lift in the tension. So tension string in the the tension in the string is T and M is acting, and the non-inertial frame means observer is inside or outside. Everybody, observer is inside or outside? Inside. Okay, and as we all knows that lift acceleration is upward means, then observer acceleration is also what direction? Everybody.
Upward.
Upward direction only. So we know that in this case the body is appears to be in what? Body is appears
Rest.
to be in what? Yes, please.
Rest.
Rest. Understanding? So now if you notice it here, all of you, so as the observer's acceleration is upward direction, then the force we are considering as a what direction? Everybody. The force
Downward direction.
is a what direction? Pseudo force. Downward direction.
Opposite direction.
That is what? Opposite direction. So non-inertial frame. Non-inertial frame. So now if you notice it, if I consider the mass M, so the tension in the string is upward direction. The force which is exerting downward direction, MA, that is what? Pseudo force opposite, and as well as the weight of the body is exerting downward direction, that is what? MG. Mg. Now you write the equation. What will happen? Non-inertial frame. I consider that pseudo force is acting opposite to the direction of acceleration. So that what will happen now? As we know, this body acceleration is 0. Then what will happen? Everybody. T is equals to upward
MA
force
plus
equals to downward force, which is equals to what? MA plus
mg.
mg. So that is what. Now NLM is what? NLM is valid or not? It is valid. Okay. So only if you consider that opposite direction, then the always keep in mind, if the acceleration of the body is upward direction, then F equals to MA. What direction? Downward direction. Understand, Rudreswar? If suppose acceleration is like this direction, then MA is what direction? Opposite direction. Clear? Understand, Laksha? Aswita? Then the NLM, the pseudo force is, that is what? Newton's second law, Newton's laws of motion is valid. Do you understand what I'm saying? Everybody clear?
Yes, sir.
All of you? So that is what. So always remember that this minus indicating opposite to the acceleration. If acceleration is forward, you take it as MA, minus backward. That is only called as pseudo force. So that's all. Then in this case, NML is applied. To apply the NLM, you should consider F equals to MA naught. FP, the pseudo force, is equals to minus MA. So this minus indicating, don't think opposite. Opposite to whom? Which one? Opposite to
Acceleration of observer.
That is what you should consider. Acceleration of the whom it is actually? Acceleration of observer. Okay? Understand? Yes or no, everybody?
Yes,
That is
sir.
now.
Yes.
Let us solve this question. Till here, understood or not? Now I'll make you very clear. Don't worry. Now observe very carefully. There is a big car. Let me take it. Now have you noticed that in your car, many things you people will hang in front of you. Am I right or wrong? All of you?
Yes, sir.
Yes or no? So for example, so there is a seating, you can make it. So there is a seating, a person is sitting here. Have you noticed that in your father or mother, definitely they will tie something hanging here in front of you in your seating. Am I right or wrong? All of you?
Yes, sir.
Yes. So let me consider there is a mass or else the pendulum. Your father is hanging the pendulum here. Okay, now your car is traveling with acceleration A in a forward direction. What direction? Everybody? Your car is traveling acceleration A in what direction? Forward direction.
Forward.
So now you see that if the body is traveling forward direction, as we know, our body mass also definitely in what direction? Forward direction. Right or wrong?
Forward.
Yes. So now, if you observe this mass M, that is what pendulum. Now you tell me it is inertial frame or non-inertial frame? Everybody.
Non-inertial.
Non-inertial observer. We are not seeing from outside. We are seeing as it inside. So it is inertial or non-inertial? Everybody. Yes,
Non-inertial.
non-inertial. So now as we know, if it is a pendulum, so all of you tell me, if it is a pendulum, now if the car moves forward direction, the pendulum will go what direction? Backward or forward? Everybody. The pendulum will move into what? It will swing into backward direction. Am I right or wrong?
Backward.
Yes or no? Everybody, please respond.
Yes, sir.
The spring will move into backward direction. That is what. So definitely it is making a theta. Angle is how much? What is the angle?
Theta.
All of you? Yes, please.
Theta.
Theta. So now let me consider again the same thing. So forget about the car. Now observer is sitting in the car. Now the pendulum from this position, it has been swinging to here. So now there is a theta it is making. So now it is moving with the acceleration A. So it is an inertial or non-inertial frame. What is that? Everybody. It is the
Non-inertial.
non-inertial. Now they're asking what is this theta? Calculate this theta. So find theta M rest in equilibrium. Theta M means mass. Find theta of M rest in equilibrium. So equilibrium means you all people knows the position. So it will comes to the back. So at this point, what is the theta it is making to attain the equilibrium position? So this is what the equilibrium position. So that is what they are asking. So as I told you, if the acceleration of the body forward direction means, now I told you that the pseudo force we have to consider what direction? Everybody. The pseudo force we have to consider what direction? Opposite to that. So that this is what the pseudo force. Am I right or wrong? Everybody? Yes,
Yes,
or
sir.
no? All of you. It is only ways to call as what direction? Opposite direction. So as if the car acceleration is forward, we should take the pseudo force always opposite to that. So that is what MA in backward direction. Am I right or wrong? Everyone understand or wrong?
Yes, sir.
Yes. So now observe only this M and draw the FBD, free body diagram. I will draw. Am I drawing right or wrong? You respond. So first, initially the pendulum is hanging here. So now as it is moves into here, this is what the position it is obtained. Now as we all knows that, you can notice it, there is a force which is acting downward direction. What is the force which is acting downward direction, everybody?
MG.
Mg. And as we know, acceleration is forward direction. So there is a tension in the string. This string only, this string. Understand, Ra? Sai Karthik? This string only swinging here. Clear, everybody? Understand or not? The string
Yes,
is
sir.
here. So the tension in the string is T. Now, all of you observe very carefully. Here is the theta means. If I take, for example, imagine here, then here also what is the angle?
Theta.
Here also angle is how much? Theta. And if the acceleration is forward means, then pseudo force is acting what direction?
Backward.
The force is acting backward direction. So that is, so now this is what is our body. So just draw the like FBD if I draw. So there is a force which is acting tension T, and here is the theta, because this theta is equal to this theta. Am I right or wrong? Mathematics. Pradosh, understand?
Sir.
Yes.
Yes, sir.
So then one force which is acting downward direction Mg, and this force which is acting, what is that force we used to call as? MA. Then if he is the theta means immediately two components will come, x component and y component. Then here what component will come? Here everybody, t
Cos theta.
cos theta, and here what will come? T
Sin theta.
sin theta. That is what you have to remember. Now, t cos theta is equals to, from this form the equation, t cos theta is equals to what? T cos theta equals to mg. And
Mg.
t sin theta is equals to what? T sin theta is equals to, all of you,
Ma.
ma. So divide both the equations, what will happen? Divide both equations, what will happen? Divide second equation with the first equation. So t sin theta divided by t cos theta is equals to ma divided by mg. So what will happen? Tt will get cancelled, will get cancelled. Sin by cos equals to something. Anybody?
Tan theta equal to
Tan theta is equals to a by
G.
g. From the theta equals to how much, guys? Theta
Tan
is
inverse of A/G.
tan inverse of a by g. So this is what, how to calculate theta when you are in a non-inertial frame. When you are in a what? Actually, non-inertial frame. Do you all understand, everybody? By considering what? By considering the pseudo force, we have to calculate it. This is how we have to calculate the pseudo force. Understanding importance of pseudo force while you are calculating the tension or theta. Now, same thing we can calculate and we can prove that in the inertial frame also it is same. Do you understand? Now you solve this. You do all understand how to find it now? Everybody clear? Everyone, please respond.
Yes, sir.
That is what. If you understand this, then shall we solve for inertial frame, everybody? Are you ready?
Yes, sir.
Yeah. So for example, so inertial frame means observer is outside or inside?
Outside.
Outside. So there is an observer.
Outside.
So definitely it will make a theta angle. Now the acceleration is this one. Now observer is outside or inside, guys? Observer is outside or inside? Outside. Ground. So he is on the ground. So means in the sense of it is inertial or non-inertial? It is the
Inertia.
inertial. Now, so let us imagine. So actual position is this one. So due to the acceleration, the body came to this position. So there is a tension in the string, and theta it is angle making. Now, as we know, it is observer. So now if you observe the observer, you tell me the acceleration of the M also appears to be in forward direction or backward direction? Yes, please. Observer is outside. So acceleration of the car equals to acceleration of this mass. Am I right or wrong? Everybody.
Yes, sir.
So
Yes,
if the observer is seeing outside, the acceleration of the mass also is appears to be in same direction of car or not? Everyone.
sir.
Yes or no?
Yes, sir.
Yes. So it will be observed same direction. So now if you draw the free body diagram for this one. So let us draw free body diagram now. So there is a force which is acting as, of course, let me consider there is an acceleration forward direction, and there is a force which is acting downward direction mg, and there is a tension which is acting t. Now, if there is a theta means, then here if I imagine, here also how much it will come? Everyone. Theta will come. So I am imagining here also theta. Then if it theta means here two components. X component, what will happen? T
Cos
theta. And here what will happen?
sin theta.
T sin theta. That's all. Now, you can check it here. So T from this, I can say T cos theta is equals to what?
Mg.
Mg. And here there is no net forces. So F net equals to Ma. So what will happen? F net equals to Ma. So only one force is acting. So this direction. So what will happen? T sin theta is equals to what will happen?
Mg.
T sin theta is equals to also Ma. So again, you got the same equations or not? Everybody? Yes. So again,
Yes,
if you divide, so what will happen? T sin theta divided by T cos theta, which is equals to Ma divided by Mg. So again, you will get what? Everybody? Yes, please.
Tan theta
Tan
equal
theta
to
is
A by
equals to A by G. Theta is equals to what? Tan
tan
inverse
inverse of A by G.
A by G. So both the cases, do you understand now? Inertial frame, non-inertial frame, how we can consider as a, if you want to apply the NLM, Newton's laws of motion in non-inertial frame, we have to consider that the force F is equals to only one new thing we are making. What is that? The force is acting opposite to the direction of acceleration. That is acceleration of whom? Acceleration of direction of whom?
Observer.
Acceleration of observer. Have you noticed that both the cases we got the same theta equals to tan inverse of A by G? Do you understand?
Yes, sir.
So that is what. So for inertial frame also same and non-inertial frame also same. But non-inertial frame we should consider one new thing. What is that, everyone? Always you have to consider the pseudo force. The force always acting opposite to the what? Direction of
Acceleration of observer.
direction of observer. That is what you have to remember it. Understand, everyone? Aswita, Purima, Aswita, Mr. Rishi, Sai Gardi, Narayan. Yes.
Yes, sir.
Pseudo force means nothing but Newton's second law, but it is always opposite to the direction of acceleration. So that is what you should understand it. So this is what, how to make the definitions, derivations for pseudo force. Now, mainly in the case of pseudo force, they'll ask us to calculate the tension. So that is what one example also I'll teach you for in today's class so that you'll understand. So if it is a pseudo force, if the observer is inside, understanding? So for example, you can see here, as I taught you today, so you can notice it if you check the spring balance. So as I told you, which is correct actually, T is equals to mg plus ma. This is what the spring balance reading. But if you are not considering the pseudo force, then spring balance reading is mg. Is it a correct or incorrect? Everybody, it is incorrect. Understanding? So that is the reason wherever the observer, you have to find the correct reading, correct tension in the string. Then that is why the concept called as pseudo force is introduced. So based upon that, let us solve an example so that you will all understand how it will be able to solve it. Now, so this one is very important. So observe, there is a lift now. There is a lift. So inside a lift, there is a spring. We are calculating now what? Spring balance. A reading of spring balance. There is a mass 1.5 kg. How much mass is it? 1.5 kg. This mass is 3 kg. And observer is inside the lift. So that you tell me it is a inertial frame or non-inertial frame. Everybody.
Non-inertial.
Non-inertial. So if it is a non-inertial frame, we have to apply the concept called as what is that?
Pseudo force.
Now imagine entire lift is traveling with the acceleration g by 10. What is the acceleration of the lift, everyone?
G by 10.
G by 10. Then means in the sense of observer acceleration is also how much?
G by 10.
Observer acceleration is also G by 10. But inside, have you noticed it? This both bodies, as they connected with the tension, same string, tension is what? Tension in the string is how much? T. And here also tension in the string is how much? T. So as we know, same string means same tension. So both the strings is acting and here it is attached to that. So can you tell me what is the tension in the spring? That is what spring force. Spring force is equals to two
2T.
tensions are acting. So which is equals to how much, Ra?
2T.
2T. This
2T.
we are all very familiar with this. Now, have you noticed that here masses are not equal? So here observer will feel both acceleration is not same. Am I right or not, Rudreswa? This body is going what? Upward direction, and this body is coming what direction?
Downward.
Downward direction. Because their masses are not equal. Am I right or wrong? All of you? Yes?
Yes, sir.
And they are asking us the question now, find the reading of spring balance. So find the reading of spring balance means what we should calculate actually? We have to calculate the what? Tension. Am I right or wrong? All of you?
Yes.
Yes, please.
Yes, sir.
So find the reading of spring balance